Let us discuss a question from HT heat transfer. So in case of a combined convection and conduction heat transfer through a plane wall, so you have a plane wall, okay, and so let's say there are some heat transfer that has to take place. So you have thermal resistance of this because of the conductivity, finite conductivity, and then you have a convection to outside medium, okay. So you have conduction here and outside you have convection. So now with the addition of insulating material with low thermal conductivity, what happens is asked. So obviously in this problem, I mean before adding any thermal insulation, the resistance is uh, there are two resistances. One the thermal resistance and the other is the conduction. So this is conduction and this is convection. Okay. So conduction is L, resistance is L by Ka, area of cross section, whereas convection resistance is 1 by Ha, right? So obviously the heat transfer will be the temperature difference at the inside and T infinity here. So that is T minus T infinity, let's say, and by the total resistance. Okay, now if I add another layer, let's say, then what will happen is there will be another conduction resistance. So resistance, obviously this resistance before is basically L by Ka plus 1 by Ha. Okay, and afterwards if I add another thermal resistance, so that will be basically L by K of insulation into A, area of cross section, plus 1 by Ha. So these will remain same. Now because of addition of another low thermal conductivity, this L by Ka will increase. Basically the resistance, conduction resistance is increasing. There is an increase in the conduction resistance. So that is correct. And because conduction resistance increases, the thermal net heat transfer reduces. So 1 and 2 are correct. Now convection resistance, nothing happens because convection resistance is 1 by Ha. So it only depends on the heat transfer coefficient. So 1 and 2 only will change, will get affected. So the answer is A. Thank you.